Welcome to qnawire.
In this exercise, we have a neutron pion represented by pi 0 that has an average lifetime, delta t, of 8.4 times 10 to the minus 17 seconds, and a mass that is 264 times the mass of the electron. And in the first part of the question, we have to find what is the uncertainty in the mass of the pion given the rest energy relation, that the energy is equal to mc squared. Well, first, let's use the Heisenberg's uncertainty principle, the energy time uncertainty principle, that states that delta t times delta E, where delta t is the uncertainty in the time and delta E in the energy, is greater or equal than h bar over 2. Now, use that delta E is equal to delta m times c squared. So we have that delta t times delta m times c squared is greater or equal than h bar over 2. So delta m is greater or equal than h bar over 2 delta t c squared. So this is h divided by 4 pi delta t c squared. And if we substitute the numbers, we have that h is 6.63 times 10 to the minus 34 joules second divided by 4 pi times delta t. Delta t is 8.4 times 10 to the minus 17 seconds times c squared. C is 3 times 10 to the 8th meters per second. So delta m is greater or equal than 6.98 times 10 to the minus 36 kilograms. So if we assume minimum uncertainty, we get that the uncertainty in the mass is 6.98 times 10 to the minus 36 kilograms. And then we have to express this as a fraction of the mass of the neutron pion. So we have to calculate delta m divided by the mass of the neutron pion. Delta m is 6.98 times 10 to the minus 36 kilograms. And the mass of the neutron pion is 264 times the mass of the electron. And the mass of the electron is 9.1 times 10 to the minus 31 kilograms. So this is equal to 2.9 times 10 to the minus 8. And this concludes our question.